In this video, I want to explain something of how basement drain systems can work. So here we have a foundation wall, and this is the floor. It's kind of a cutaway view. Now, there's really two main situations you're going to run into, and this first one is the floor drain system. So this is what you're facing when the drain of your floor ultimately is lower than your house. And you're going to know you've got that situation because you've got a floor drain somewhere in your basement floor. It'll just be a round, usually perforated disc about 4 or 5 inches in diameter, and it will be a drain. So any water that's on the basement floor can drain down into it, but it's also connected to something larger and more extensive. So if you have a modernish sort of basement that hasn't had any plumbing rough-ins to it, you're going to have a floor drain like you see here, and that's just about it. All the other things on this drawing don't exist yet, and I want to explain how you can add them and what has to happen. Now, this isn't a full-blown course on plumbing. That could take up a course all on its own, but it is to give you, this lesson is to give you an idea of how things go together and what you're going to be up against. So starting with the floor drain, the first thing I want to bring your attention to is this thing over here called the backwater valve. As I've explained in the course, this is a fancy sort of one-way valve. It lets sewage leave your house, like you see here, but it prevents sewage from coming back up into your house and bubbling right up through the floor drain and filling the bottom of your basement with your sewage and other people's sewage too. Now, this sort of thing happens to thousands of homes each year when municipal sewage systems are overloaded, usually because of a lot of rain. So a backwater valve is definitely very cheap insurance. You're going to have to break through the concrete floor or have someone do that to install it, but it's not as big a deal as it sounds. So that's thing number one. Now let's just say you want to install a bathroom in your basement. It's very common. You are going to have to tap into this existing line. So the floor drain goes down, and under normal circumstances, what you'll find is that it makes a turn, a 90-degree turn, and starts to go horizontally, and eventually out away from your house and down to the main sanitary sewage line. So if you want to add a bathroom, you're going to have to add these pipes here. One leading from a toilet, another from a sink. You're probably going to want to have a shower or a bathtub or something like that. So to add these pipes, you're going to have to break up channels through the concrete so you can dig down into the soil that's underneath your basement and add these pipes. They need to be sloped in the right direction and all that usual plumbing stuff. But the purpose of this video is just to give you an overview of what has to happen. So you need to break up the floor, install the pipes in a rough-in sort of way. So they would end somewhat above the floor, and then these other things would be added later. Here there's a flange, a toilet flange, which would be kind of at floor level, and the toilet would bolt to it, and it would make a sewage connection that would work and keep things contained. So I want to bring your attention to something that's easy to miss, especially if you're doing this sort of plumbing work yourself and you've never done it before. So here we have a vanity and sink, and coming out of the bottom of the sink is what's called a trap, which is a curved section of drain pipe, and the purpose of that curved section is to retain some water in it, and that stops any sewer gases from being able to waft up into your home. The water acts as a kind of a seal, and it keeps those sewer gases out. So we've got a situation here. The sink is tapped into the main drain. The toilet's tapped into the main drain. And imagine you're flushing the toilet. So there's this big blast of water that goes down the pipe, traveling this way. There's a fair amount of force to this because water weighs a lot, and it is going downhill a little bit in this pipe. But eventually that big blast of water stops, and there's just air behind it when the toilet has finished flushing and the tank is filling and whatnot. So behind the big blast of water, as it travels down, there's going to be a tremendous amount of suction built up. Just because it's creating a vacuum. The water's creating a vacuum as it moves down along the pipe. And let's just say that vacuum continues here past the point where a sink or shower might connect to that system. Well, the suction is going to want to draw all the water out of the trap because it's sucking on these pipes as the water travels down. And if this situation, the setup you see here existed without this vent that you see drawn here, then two things are going to happen. First of all, most of the water is going to be sucked out of the trap, which means the trap's not functioning properly anymore. It doesn't have enough water in it to seal out the sewer gases. There might be a little bit of water left in the bottom of the trap, but if there's a continuous pathway with no water in it through here, then you're going to get sewer gases wafting up here, making your basement bathroom smell bad. The rush of the toilet water is also going to cause a kind of a glug glug sound as it tries to suck the water out of the trap. I should mention too that this isn't just a function of toilets. This is anything that empties into a drain. When that section of water is flowing down here and there's no other water behind it, it creates a powerful suction. So this could be a bathtub or another sink or a toilet like you see here. So the solution to this suction problem in the world of plumbing is to install some sort of a vent. So the vent allows air to be drawn into the system. So in this case, the suction doesn't ever get to the water in the trap. It just, the suction is satisfied by air being pulled into this vent. Now, normally, these vents extend all the way up through the house and they go through the roof. That's why on most houses, you see these pipes, maybe a foot or two long, not too big in diameter, and they're just sticking up above the roof and they're open on top, and that's the vent. That's the kind of standard style vent. But if you're working in a basement, getting a vent pipe all the way up through your house so that it doesn't interfere with things that are going on in your house, room layouts, whatever, and it goes through your attic, and it has to go through your roof with all the appropriate flashing and waterproofing required, that's a really big hassle. So this device here, an under-sink vent, is the solution. It's a one-way valve. It's a one-way air valve, essentially. So air can flow into this, but sewer gases and other stuff can't get out. It only allows flow one way. Now, where you live, there may be varying regulations on how you need to use these things or how many of them you can use in a given installation. I'll leave you to figure that out on your own, what the local conditions are. But this sort of thing is a real lifesaver. It makes the job of plumbing properly a lot easier when it comes to the venting. Now, would this vent here, as I've drawn it, be enough to stop the water from being sucked out of the toilet? Because the toilet is essentially one big trap. I mean, there's a bowl, but the passages, they take a kind of a curved route, so that and the water in the toilet also, as it lays in there, helps to seal out the sewer gases. So you want to have a vent like this, maybe within 3 or 4 feet of where the toilet connects, and as close as possible to the sink as well. Because if it's too far away from the item in question, then the suction is going to build sufficiently to cause some problems before that suction ever gets a chance to be relieved by the vent, whatever kind of vent that is. So there are regulations about how close the vent has to be to the item in order to vent properly, and you're going to want to look those up. As I said, this isn't a detailed lesson on how to do plumbing, because that's a job in itself. But this is just to give you an overview of how the drain business is done in basements, and the kind of challenge that you're likely to face with venting way down there. Although most basements have drains in the floor and the drain leaves the building below the bottom of the basement floor, not all homes are like this. Some homes have a drain pipe, a main drain pipe that leaves through the wall, partway up the wall, like you see here. And in situations like this, you can't rely on gravity to get rid of the sewage that you're going to generate in the basement. For that, you need a system that's got some sort of a pump. And that's what I've pictured here. Let's start by looking at this. This is a macerating toilet. I've called it a Saniflow toilet because Saniflow is the world leader in this sort of thing. Imagine a regular toilet. It's got water in it, and it's porcelain, and it's got a seat. But when you flush it, the wastewater doesn't go down through some large diameter pipe, like 3 or 4 inches in diameter. Instead, the sewage goes into another part of the unit, which is the sewage pump. In this case, the toilet also grinds things up. So it's not just going to pump it up and out into your main drain that's above the floor, but it's also going to grind it up. That's where the word macerating comes from. Now, this sort of a setup does take a little bit of electricity. You're going to need a 120 volt outlet somewhere to operate this sewage pump. But the good news is that you only need to connect a 3/4 inch diameter pipe to the sewage pump because everything's all chewed up. A pipe that small is going to do the job for you. So that's part one of the arrangement. But let's say you want a shower or some sort of a vanity sink. You're also going to need to get that water up high enough so it goes down to the main drain. Now, these Saniflow toilets come in different models, but there are models that are meant to handle more than just the sewage produced by the toilet. And that's what we have going on here. So if we're dealing with a concrete floor and the sewage pump and toilet are as low as it can be, if you're going to go with a shower or a sink, you need to raise that a little bit, perhaps on some sort of a false floor or just to raise the shower itself, because you're going to need to have room for the drain to go down and then to curve and travel horizontally. And in this case, it's the same old 3/4 inch pipe that we were talking about before. But that pipe does need to be sloped a little bit so that it flows with gravity, because it's going to flow this way, and it's going to go into the sewage pump as well. So whenever someone's taking a shower or using the sink or flushing the toilet, then the sewage pump will detect that, and it will kick on. It will chew up everything, or attempt to chew up everything that goes through it, and then pump this stuff up and out. So this is the way it works. You're going to want to arrange things in your basement so that this 3/4 inch pipe, if it has to drain anything else other than the toilet, you're going to want to locate that pipe along the wall somewhere so it's out of sight. Maybe even behind something. You know, maybe this pipe would travel horizontally through a utility part of your basement, maybe where the furnace is or something like that, and then pop back into the bathroom, your basement bathroom, when it connects to the sewage pump. You're going to need to be a bit creative about how to work this and lay it out so that it works as well as possible. You're also going to need to do some fooling around here to see how high you have to raise the base so that you have room to get the pipe in and for it to go horizontally. You're going to want to make this raised area accessible too, because who knows, someone might need to get in there someday. So as much as possible, you're going to want to leave it accessible. And that's really the only way that you can get any kind of sewage to drain away in a basement where the outlet is partway up the wall like this. Now, most of the times this is going to happen in rural areas, in my experience, because if you're in a city, in any kind of a subdivision, the whole shebang is laid out so that the drains can exist below the houses. But many times, if you have a septic system, the septic tank can only be so far below the ground for it to remain accessible, which means that this pipe, the height of this pipe is kind of predetermined in a way, because it's got to be just a little bit higher than the septic tank. So this sort of an arrangement here with the wall drain is something that I think you'll find in rural areas where there is no municipal sewage system. But no matter where you find it, you can solve the problem with one of these macerating toilets that also handles other wastewater.